we're on. Okay, so again, Dijkstra's algorithm is what we're doing. Finding the shortest distance from a start location, in this case 0, to any vertex. And we're going to complete a chart that will keep track of the shortest path from 0 to every vertex. So we will know all the shortest paths. Okay, so then if there were any follow-up questions, we'd have all the information we need. So our chart consists of 3 columns. One of every vertex, which I've already filled out, 0 through 8. One is the distance from start. So 0 is our start. 0 has a distance from 0 to 0, right? And then the third column is the previous vertex. So what was the last vertex visited in that total distance? And this will make much more sense once we start filling it out. You could argue that I'm actually going to have a fourth column because I'm going to use this column to keep track of every vertex that we have visited, and we're going to visit them all. And not necessarily in numerical order. So I'm just going to put a little X next to each one we visited. So we're going to visit, we're going to do 2 things. We're going to visit a vertex, and we're going to investigate each vertex it's connected to that we haven't visited yet. So to begin, I begin by visiting the start. So I'm currently at 0. In fact, I might use a little pen or something here to denote that. Okay, so I'm currently at 0, right? I'm investigating every vertex connected directly to 0. So that includes 1, 1, and 7. I'm visiting or investigating those. No, I shouldn't say visiting. Visiting is where I'm at 0. I'm at 0, looking ahead to 1, looking ahead to 7. So we're going to start filling out our chart. So I can fill out our chart once I start investigating. So 1 has a distance I see from 0 of 4. How would I get to 1? Through 0. Okay. I can also see 7. Notice that these are blank. Everything has to be filled in by the time I'm done here. And we might update things as we go, just heads up. Okay, anyway, so I can see 7. 7 has a distance from start of 7. And I would get there through 0. Okay. All right. Let me make this uniform here. There we go. So now I'm done visiting 0 because I've investigated everything connected to it. So I'm going to put an X there. I'm then going to visit the vertex that has the shortest distance to 0. Anything that's blank you can assume it has an infinite distance. We haven't figured it out yet. So 1 would be that next one. So I'll put an X there, and I'll draw on that to denote that that's where we are. So I'm visiting there. Again, 7 is still connected, so I can check that out. 8 is connected, and 2 is connected. I'm going to investigate each of those. So I'll just do it in order here. 2 as a distance. Remember, we're currently at 1. I'm at a distance of 4. So every distance I see ahead of me would be, I'd need to add 4 to it. So 2 has a distance of 12 from the start, right? Through 1. Right? This chart may get changed as we go through this, right? Sometimes it doesn't, sometimes it does. We'll have to wait and see. I'm going to investigate 8. 8 has a total distance of 9 because 4 plus 5 is 9. Put that there. And how did I get to it? Through 1, right? The previous vertex is 1, even though, yes, it's 0 as well. I'll show you how this starts to tell, this column starts to tell a story here as we move along. Okay, and what else? 7. I need to investigate 7. Now, I already have information for 7, but I always got to check to see if I found a shorter route. So it's 11 from 1, but of course I'd have to add the 4. That's 15. That's not shorter than what I currently have, so I let that go. All right, so now, let me rather have that there. Okay, so now I've visited both of these vertices. I check my chart and find the shortest distance to 0, and that's 7. So that's where I'm going to visit next. Okay. I'll fill this in. Okay, so now I'm currently visiting 7. I'm going to investigate 8 and 6. Those are the 2 directly connected. I don't need to investigate 1. I've already visited it. Okay. So 6 has a distance. So currently I'm at a distance of 7. I would add a distance of 1 to get to 6. So 6 has a distance of 8. You get that there? There we go. 8. And the previous vertex from 6 would be 7. Okay. Then I'm also investigating 8, right? I've already got information filled out, but do I need to update it, right? I'm at 7, I'd have to add 8, that's 15, that's more than this. No, I'm only interested in things less than. So I'm gonna leave 8 be. All right, I'm done with 7. Sometimes this will start moving along faster as I don't have to explain every little thing. It'll go much faster for you guys once you've done this a few times. Okay, so next shortest distance would be vertex 6. So we'll visit 6. I'll mark it. Notice that I might bounce back and forth as I start filling this out. Okay, so at 6, I'm at a distance of 8, right? So the only thing directly connected to it would be 5, and that would give that a distance of 11, right? 8 plus 3, 11, that'd be through 6. That's it. Okay, next shortest distance would be 8. So let's visit 8. Put an X there. Fill that in. Now this is from going from 1 to 8 here. Excuse me. I can investigate 2 and I can investigate 3. So let's investigate 2. I'm at a current distance of 9. 2 is 1 away, so that would make it 10. Notice that that is shorter than the distance I have there for 2. So what I'm going to do is, oh, I don't have a strike through option, do I? Sorry, I was trying to make this all fancy, but I'm just going to replace the 12 with my new total, which is 10. Okay, now I have to update the previous vertex because now instead of going from 1, I came from 8. That's actually a shorter path. So we found a shorter path for 2. This is what I mean by updating. Usually when I write this by hand, I'll cross out the 12 and write the 10 in there, and you can see the updates as they happen instead of replacing. But okay. Then 3, I need some information for 3. Remember, I'm currently at 8, which had a distance of 9. I'd have to add 9 to it. That's 18 for 3. Going through 8. All right. So next, I'm done investigating from 8, right? What's my next shortest distance here? Looks like these 3 are the options. So 10 is the shortest at 2. Okay. So now I'm visiting 2. The only thing I need to investigate is 3 because everything else connected to 2 I've already visited, so I don't have to worry about those. So 3, I'm currently at a distance of 10. I'd have to add 9 to it. That's 19. That's not shorter. So there's nothing I can do there. Okay, nothing to do. Moving on. I have 11 and 18. So I'm going to choose 11, the distance of 11 at 5. So now I'm visiting 5. Okay. So now what am I going to investigate? 3 and 4. Moving along, right? So I'm currently at a distance of 11. To get to 3, I would add 11 of this, 25, clearly not shorter. So I won't do that. 4 doesn't have any information, so I need to update that. 4, again, I'm at a distance of 11. It says so right there on my chart. Add 10 to it, make that 21. I get there through 5. Okay, that's it. I'm done visiting 5. I'm going to put my X there. The next shortest is 3, so I'll put my X there. I'll visit 3. This has a distance of 18, so it's 18. 18 is what I'm adding to everything, right? But I'm only need to take a look at 4. Add 9 to it would be 27. That's not shorter. Nothing to update there, and so then I'm officially done. I could go back and visit 4, but there's no place to go, right? I already had. So the last one you're kind of done with. I'll put an X there to be official. We've completed this. All right, so what if I come back and I say, hey, what's the fastest route to get to 3 from 0? You go, oh, 3 has 18. That I get there through 8. Well, where would I go from 8? How did I get to 8? 8 had a previous vertex of 1. Look at 1. 1 had a previous vertex of 0. So you could always work your way backwards to find that route. So it'd be 0, 1, 8, 3. Right? What's the shortest route to forward, to all, the one all the way over there, right? It has a previous vertex of 5. Right? Then I look up 5 on this. It has a previous vertex of 6. I look up 6 in this chart, has a previous vertex of 7, and 7 has a previous vertex of 0. So this column tells a story, along with the vertex column, of how to get from every single place. And of course, you have the exact numbers right here in this column. All right, that's how to complete a chart for Dijkstra's formula. Let's stop this here.